So the idea here is if you take this triangle, so again, it just means it's a logo that is in the shape of a triangle. Okay, what I'm going to do is I'm going to write my longest side here on the bottom. And the reason for that is when I draw in my altitude, right, because if this is my base, I need to know this corresponding height, correct? And then I can take 1/2 base times height. Right? So if I use 7 or 8 as my base, then I don't know if I need to extend the triangle out. Right? But if the longest side is my base, then I know there's no way I need to extend out to, because I'm not going to have an obtuse angle where this intersects. Okay? So this is the first step. Next, I can go ahead and label my other two sides. I'll call this 7 and 8. Okay? So in order for me to find the area of this triangle, area is 1/2 base times height. I established that my base is 10. And so what I need to know is what this height is. Well, this height can be formed with either of these right triangles, correct? The one to the left or the one to the right. So I'm just going to arbitrarily choose. I'm choosing this one here on the left, so I'm going to call this theta. Now, a number of you found all of the angle measures, which is fine. Hey, but you only need to find one. Right? If it's this triangle, you need this angle. If you choose this triangle, you need this angle. So what I need to do is find theta. Well, what can I use to find theta? I have 3 sides and an unknown angle, so law of cosines. So I'm going to start with, again, my unknown, and the side opposite it are always going to be my extremes, my first and last elements. So I'm going to take my 8 squared, set it equal to the sum of the squares of the other 2 sides, minus twice the product of those 2 sides, times the cosine of the angle opposite that, which is the designated angle, theta. Okay, so I'm going to use my TI-89 and its solve feature, and I want to solve for x. Now remember, because this is a cosine, a trig ratio, I can't solve for the variable embedded inside that ratio. I need to let this whole thing, let x be that whole cosine ratio. So here when I go in to calculate this, I solve for 8 squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times x, right? My x is representing the whole cosine ratio. And I want to solve for x. I didn't put a decimal anywhere in there, so I'm going to hit the diamond button so my answer displays as a decimal. And I get my ratio. My ratio is 0.607 approximately. And that's what my x value is. And my x value represented cosine of theta. So if I want to solve for theta, the actual angle itself, I can take the inverse cosine of that ratio, and that's going to give me my angle. So here, if I calculate inverse cosine of this ratio, I'm going to go ahead and get rid of my x equals here. I get my angle to be 52.6 approximately. Now, when I calculate, even though I rounded it here, I need to make sure I use the exact answer in all my calculations. So I still haven't found my height yet. But what I've done is I've reduced this problem now to a problem where if I just gave you this information, this triangle right here, and I told you the angle of 52.6, the hypotenuse of 7, can you find h from that? Which trig ratio relates this information? So with respect to the angle, I have an opposite and a hypotenuse, so that's related by sine. So I can take the sine of that angle, 52.6, set it equal to my opposite h divided by my sine, or my hypotenuse 7. And so I can solve for h by multiplying both sides by 7. So now I have my height. Okay, so when I do my final calculation here, I'm going to go ahead and rewrite this here really quickly. So 7 times the sine of 52.6. And so now when I do my calculation, I have 1/2 of 10 times 7 times the sine of this 52.6. I'm going to highlight my exact answer. And when I do this, I get my solution, 27.81. The units are inches, area is two-dimensional, so we are looking at square inches for our answer. Okay.